Hey guys, what is up? And welcome to this presentation on forces in action, which is P2.3. So, stretching springs, forces can stretch, compress, or bend objects, but to do so you need more than one force. For example, if you think about how you stretch a spring, you have to have two forces pulling the string at either end. If you just had one force, it would just move the spring, it wouldn't stretch it. And materials which return to their original shape when they are stretched are called elastic, and materials which remain in the shape they are stretched to are called plastic. However, in 1660, Robert Hooke found out that springs were special because when they're stretched, force and extension have a linear relationship up to a point, which means that there is like an exact relationship between them. For example, extension is always 2 times whatever force is. And the point where the linear relationship ends is known as the limit of proportionality. And there's also an elastic limit somewhere, which can be at the limit of proportionality or either side, which is the point where if you stretch the spring any further, the spring will not return to its original shape. It will be stretched permanently. So Hooke's law is that if you double the force on the spring, the extension also doubles. And the formula is that the force exerted by a spring is the spring constant times the extension. However, this formula only works up to the limit of proportionality. And if you plot a graph of extension by force, the gradient is the spring constant up until the limit of proportionality again. So the spring constant tells you how stiff the spring is. So when you stretch a spring, you do work as you're doing force over a distance. But to work out the energy, you must use this formula. The energy transferred in stretching, also known as elastic energy, is half times the spring constant times the extension squared. So you can also obviously stretch other materials like elastic bands. However, they do not have a linear relationship, apart from glass actually does, but you have to put on a lot of force for a very small extension. And all materials will store energy when they're deformed, and some transfer energy back, such as tennis rackets, because we want them to transfer the energy back so that they go back into their original shape. Whereas other objects, such as crash barriers, are made to stay in the deformed shape that they're put in, so they retain the energy when they are deformed. So gravitational fields. A gravitational field is a region where mass experiences an attractive force, and all matter has a gravitational field that causes attraction. However, only huge objects like the Earth have a force that is strong enough for us to notice. And the gravity force is mass times the gravitational field strength. And gravitational field strength, also known as G, is a measure of force on an object with mass of 1 kilogram. And the force of gravity also depends on how far away the objects are, as if the objects are closer, the force will be stronger. So weight and acceleration. Weight is what we call the force of the Earth on an object, and it is measured with scales or a Newton meter. So weight is just mass times the gravitational field strength, and on Earth's surface the gravitational field strength is equal to 10, or 9.81 if you want to be more accurate. But on other planets it is different. For example, the moon, obviously that's not a planet, but the moon is roughly a sixth of the Earth. And acceleration due to gravity, like the gravitational field strength, uses the symbol G. Because here you can see that gravity force is mass times gravitational field strength, as we saw before. But resultant force is mass times acceleration due to gravity, which is the F equals ma formula, which means that the acceleration due to gravity is equal to the gravitational field strength. So it's about 10 meters per second squared. Gravitational potential energy is the energy transferred by lifting an object, and it is mass times height times gravity, or gravitational field strength. So in turning forces, the force acts around a pivot, and so a turning effect is known as a moment. And the further away something is from the pivot, the easier it is to turn. So the further away the object is from the pivot, the easier it is for you to turn. So the moment of a force, measured in Newton meters, is force times distance, and the distance is always at a 90-degree angle to the force. For example, in this picture, the distance is 2 meters, not the length of the plank, I guess. So you can balance a seesaw with, for example, a mouse on one side and an elephant on the other, if they're in the right places and you have a long enough seesaw. So an object is balanced if the anticlockwise moments are equal to the clockwise moments, and that is the principle of moments. So simple machines, a lever is a force multiplier, and it transmits forces by rotating without a pivot, because as we saw before, the force also depends on the distance. So if you are far away from the pivot and the load is close to the pivot, you only need a small effort to lift a big load. The effort is the amount of force you put on, and the load is the amount of force that the lever exerts on the object. So the ratio of load to effort is called the mechanical advantage, and you find that out by doing load divided by effort. And the work done by you is always equal to the work done by the pivot. But obviously the force will differ depending on the distance. And the gears also work like this, as bigger cogs have a greater force with the same work. So hydraulics, if you fill a bag with water and make holes, the water leaves at 90 degrees to the surface, as the pressure of the water makes forces which are at right angles. So the pressure is the force normal to the surface, or 90 degrees to the surface, divided by the area of that surface. So a machine that uses liquids to transmit a force is called a hydraulic machine, and it uses this formula. So obviously if you increase the area, you will also have to increase the force, since the pressure will remain the same throughout, and you can see that in the diagram in the bottom right. So a hydraulic machine is also a force multiplier, as it takes a smaller force and creates a greater force. And an application of this is hydraulic brakes in a car. Thanks for watching, guys. Have a good day.